If A is equal to this matrix, then A square is equal to. Just multiply A with A and let's see what comes out. You have this 1, 0, 0, 0, 1, 0, A, B, negative 1. Multiply it again with this one only. 1, 0, 0, 0, 1, 0, and A, B, and negative 1. Okay. So what will be the result? See, 1 into 1 is 1. 0 into 0 is 0. 0 into A is 0. So first row with second column. Again, everything will be 0. 1, 0, 0, 1, 0, 1, 0, 0, B, 0. Third also same thing. So when you multiply first row with the last column, you'll get 0. Okay, so it is coming like a unit matrix, but we have to just see the second one. 0, 0, 1, 0, 0, A, 0. Now this middle one, second row with second column. 0 into 0, 1 into 1, 1. And 0 into B, 0. So it is very clear that it is going to come as unity matrix. It is unit matrix, or you can call it as an identity matrix. This is nothing but I3, identity matrix. If A is this, then A raise 4n equals. So you have to be very clear about the complex numbers, because in complex numbers, this I square is equal to negative 1. So we'll use it here. Either we will go along with I till the end, or we can just change I square equals negative 1 wherever, from the start actually. Okay, so there is a repetition here, and finally something will come which will be multiplied. If multiplied by itself, it will come again. So that is, you have this A, and this is also A. So A square we are taking, I 0, 0, I. This is I 0, 0, I. So I into I is I squared, and then 0 into 0, 0. So leave it. Now first row, second column. I into 0, 0, and 0 into I is 0. So it will come 0. So this will be the pattern, okay. Now second row and first column. 0 into I, 0, I into 0, 0. Now 0 into second row, last column. 0 into 0, I into I square. So what do you get? See, I square is negative 1, 0, 0, I square is negative 1. This is your A square. Now what will we do? We will find out the A cube. A cube is A square into A. A cube is A square into A. So we'll multiply this A square, that is this result, with A. So whatever we got, that is, I replaced I squared with negative 1, okay. So minus 1, 0, 0, minus 1 multiplied with A. That is the original matrix. I 0, 0, I. So now it's very clear what we are going to get. It will be simply I into minus 1, I into minus 1 in the diagonal. That is, this I into minus 1 and 0 and 0 will give you 0. Here also minus I. This is just, we know because we have already done one part. So A raised 4 is what? I can multiply A cube with A cube. Otherwise, you would have done A square into A square also. That is also possible. But A cube into A, rather than multiplying 3 times A square, A cube and A4, you could have done A4 as A square into A square. So minus I into I here, so minus I square, and in the second part of the diagonal, it will minus I square. I square is minus 1. Just put minus 1, minus is plus, 1, 0, 0, 1. Now this is A raised 4n. So it can be written as A raised 4 to the power n. But what is A raised 4? It is an identity matrix. So when you take the identity matrix and you multiply it any number of times, identity matrix will give you results same as the identity matrix. Okay, I square, I4, I10, I50, doesn't matter. You will always get an I. Okay, so this is your identity matrix, I. The answer is C. If A and B are two matrices such that A, B equals A and B, A equals B, then B square is equal to. So this B, A and B, multiply both with B. So I am multiplying B, B with both of these. Right hand side B square. AB is equal to what? In place of A dot B, you can replace it by A from here. And now BA is equal to B from the second one. So B is equal to B square. Please remember, because the question is coming, we are going to utilize it. So B is equal to B square. Here again, same thing we have to do, because AB is equal to A and BA equals B, and A and B are square matrices. So B square equals B, we have already just now in the previous question, we have proved it. Because AB is equal to A, BA equal to B. And just we saw B square equal to B. Now, whether A square is equal to A or A square not equal to A, that we have to see. That means A and C are the correct option. It can be only A and C. It cannot be now B and D, because we have just seen in the previous question. B square is actually equal to B. It is not equal to. These options are incorrect. Now here, AB, we are multiplying A, means in the first equation. So because we need A square. So we have A square. This is ABA. So this, you can write AB as A. No, you will get A square. So it will not work. So in place of BA, you can write B. So in place of BA, write B, because BA is equal to B. So it will be AB equals A square. What is AB? AB is also given as A. AB is A. So A equals A square. So B square is equal to B and A square is equal to A. So please remember this also, because we are going to utilize it in this question, this one. If A and B are two matrices such that AB equals B and BA equals A, then A square plus B square. Okay. See, A square was equal to A, we just saw, and B square is equal to B, we just saw that. So A square plus B square is what? A plus B. Okay. So just have to don't worry about the left and if you really want to do it, you can do like this, which I've given. Okay, this raised to power k is identity matrix. Then the least positive integral value of k is, means for that value of k, when this left hand side will become an identity matrix, we have to find when it will become an identity matrix. So this will not come in MCQs, because it will take a long time. It is actually a 5 marks question, but still we are going to do it here. But I'll show you how to do it one by one, because doing it will take a long time. So I hope you are comfortable with the matrix multiplication. So when you take the A square, you have to multiply A with A. That is, first row, first column I am multiplying. Cos 2 pi by 7 with cos 2 pi by 7, cos square 2 pi by 7. Minus sin 2 pi by 7 and sin 2 pi by 7. That is going to be minus sin square 2 pi by 7. So this is how you have to multiply first row with these two columns of the next matrix, and second row with the two columns of the second matrix, and just write what you are getting. Now what do you get here? You have to use the trigonometric equations, because cos square is theta minus sin square theta is cos 2 theta. Cos 2 theta is what? Because theta is 2 pi by 7 here. So it will be cos 2 into 2 pi by 7. That is going to be cos 4 pi by 7. So this is the catch. Everywhere you have to use this. And what about 2 sin theta cos theta? 2 sin theta cos theta is sin 2 theta. Sin 2 theta. So sin into 2 pi by 7. So sin 4 pi by 7 will come. Right? Please keep the sign like that, because sign will also come negative positive like that. But these are the equations you have to use. Now AQ will be A square into A. Why we are doing AQ? Because the question is saying to check each and every of them. So we'll multiply this. When you multiply, I hope you'll be able to multiply properly. Then there will be an equation we have to use. That is, cos A cos B minus sin A sin B will come, if you take negative from here outside. And then we have the sin A cos B plus cos A sin B. So you have to write cos A plus B and sin A plus B in place of cos A cos B minus sin A sin B and the other equation. Now A raised 6, because A4 is already done. In the options, I am taking the options. 3 I have checked, 4 I have checked. Now let us check for 6. A raised 6 can be easily done by A cube into A cube. Right? So let us multiply A cube with A cube. What do you get? So this A raised 6, when you multiply, you will get again a matrix, and we have to apply these trigonometric equations again. It can be this cos A plus B, sin A plus B, or cos square theta minus sin square theta like this. Now, I hope that A6 you have done. Now multiply it again with A, because A raised 7 also we have to check. When we do this finally, A raised 7, you will see, because one time this has come, 12 pi by 7, all these numbers are normal. But 14 pi by 7, when you divide 14 by 7, it will be 2 pi. Now cos 2 pi has certain value, which is actually equivalent to the answer, because cos 2 pi is cos 180 degree. Cos 180 degree is equivalent to cos 0 degree. The sign, if I don't take the sign into consideration. So 1 will be there. And sine 360 degree, sine 0 degree, sine 0 is 0. So it is an identity matrix. So this matrix to the power 7. So K has to be 7. So that you get the identity matrix. So you have to check it for 3, 4, 6 and 7. That is why we didn't check for 5, I guess. If the matrix AB is 0, then you just see that when we are multiplying two numbers, what can happen? Either one of them is 0 or both of them are 0 in normal terms. But when we are dealing with matrix, the two matrix cannot be 0. They have some value, but still the multiplication or the matrix multiplication can give you the result of 0. For example, A is 0, 2, 0, 0. This is our matrix. B is 1, 0, 0, 0. They both are not null matrix. But when we multiply, it's going to give us 0. That is the null matrix. Okay. So if the matrix AB is 0, that is not necessary that either A is 0 or B is 0. A is given like this. What is A raised n? A raised n. See, this matrix, if you take A common, it will be simply the identity matrix. And when you take the identity matrix to the power n, it will only come as identity matrix. But the A you have taken outside, that is the scalar, it will be A raised n. So ultimately, it will be the C part, answer C part. But I'll show you. This is A. This is a scalar matrix. So we'll do it properly, but I'll give you a trick here. Just take A outside. I'll show you that just now. So when you multiply this, A 0, 0, 0, A 0 and 0, 0, A. All other will be 0. Only the diagonal part will become A square, because A into A is A square. 0, 0 is 0. 0, 0 is 0, limit. The first row, second column. A into 0, 0, 0 into A, 0, 0 into 0, 0. Now first row, third column. A into 0, 0, 0 into 0, 0, 0 into A, 0. So there is a proper analogy and proper pattern. Now second row with the first column. 0, 0 into A, 0, A into 0, 0, 0 into 0. Now second row with second column. 0 into 0, 0, A into A squared. And 0 into 0, 0. So this is what you are going to get. A square in the diagonal. So when you take A cube, it will be A raised 3. When you take A4, it will be A raised 4. A raised n, it will be A raised n. Okay. So you can just directly write C. Just take A common, and that is going to be identity matrix to the power n. That will come again. If AB are square matrices of order 3, A is a non-singular and A into B is a null matrix, then B is. See, non-singular, singular we have not discussed. We are going to see in the determinants. But I'll give you a hint. Singular matrix and non-singular matrix, if the determinant of the matrix is 0, then they are called as singular and non-singular. Okay. If it is singular, that is the determinant has to be 0. So if A is a non-singular matrix and the determinant of non-singular matrix is non-zero, because as I said, a singular matrix, the determinant has to be 0. So B has to be a null matrix. If B is not null matrix, you won't get AB equals 0. Okay. So the answer here is a null matrix. Let me tell you again. Since A is a non-singular matrix and the determinant of non-singular matrix is non-zero, that is, it has some value, B has to be a null matrix. So we have done question 8 like this, A raised n. Same thing we are going to do here. See, this is a simple, there's a simple trick. Take n common from here, and that will be identity matrix. And when you multiply identity matrix with any matrix, that very matrix will come. But since we have taken n common, this will get multiplied with matrix B. Even if you do the proper matrix multiplication, n into A1, 0 into B1, 0 into C1, and A1 will come. You can try out any of the combination. Okay? Because in this first row and second column also, and A1 will come, other will be 0. Right? So what I'm trying to suggest here is, this multiplication you can do, you can find out the answer. But the trick here is, the first matrix you can take n common, that will be identity matrix. And we know when we multiply anything with the identity matrix, that thing will come. And since we have taken n outside, it will get multiplied with every other element inside. So the final result will be simply n into b. That is, I am taking n common. This is the identity matrix. Because you can take n common. This is a scalar multiplication. Now take the b matrix, multiply. B with I, that is identity matrix, any matrix will be B, this same matrix B. N into B, that will be the scalar multiplication. So n into B will come. Okay. So everything will be multiplied by n. Right? N into B is the answer. Now this A is 1A01, then A raised n. So what we will do, you will see a pattern here. That is, when we multiply A with A square, I'll just find A square and you'll know the pattern. So let us do this A into A properly first. So this is 1 into A. You just assume that this is 1 into A. And we multiply it with 1A01. So A with A multiplication is going on. A square we are trying to find out. 1 into 1 plus A into 0, leave it. 1 into A into 1 is A. 0 into 1 is 0 and 1 into 0 is 0. 0 into A is 0 and 1 into 1 is 1. So what do you get? See, this is 1, 2A, twice of A. So initially I told you that this is 1A, now it is 2A. So if you do A3, this will come as 3A. You do 4A, it will come 4A. So this pattern is, when you take A raised n, because as I said, A3, 3A, A4, 4A. This means, so whenever you do A raised n, it will be 1 and A01. This is your answer A. Now A is this and B is this. A into B is I3. I is the identity matrix. Then X plus Y equals. So we just have to multiply it, and when you see, one of the term will be X plus Y. Okay. So we'll properly multiply it, and then we will equate it to the identity matrix. A is this 1, 2, X 0, 1, 0, 0, 0, 1. This is our first matrix. The next one will be 1 minus 2y, 0, 1, 0 and 0, 0, 1. Now let us multiply. 1 into 1 is 1. 2 into 0 is 0. Leave it. X into 0 is 0. So 1 into minus 2 is minus 2. Minus 1 into minus 2 into 1 is 2 and x into 0 is 0. So minus 2 plus 2. 1 into y is y. 2 into 0 is 0 and x into 1 is x. X. Now the lower part, if you see, they are exactly like the identity matrix. Okay. So you will get exactly similar value, that is 0, 1, 0. I am not doing it. I hope you will be able to do 0, 1, 0. The lower part will be like the identity matrix. And this is equal to the I3. That is 1, 0, 0, 0, 1, 0 and 0, 0, 1. Right? Okay. So what do you get? If you see, y plus x is equal to 0 in this case. Y plus x is equal to 0. So the question is asking about y plus x only. That is x plus y equals 0. So this is equal to 0. Okay. I hope you'll be able to do this. A and B is this. A plus B whole square is A squared plus B squared. Then value of A and B are. So let us do step 1. That is, let us see what we get from A plus B whole square. So in this A plus B whole square, we will do this opening proper, A into B and A into B. Please remember, A plus B whole square cannot be written as A square plus B square plus 2AB. It cannot. It has to be written with A plus B into A plus B. So this is the proper multiplication we have to do. So what do you get? A plus B into A plus B. A into A is A dot A square. A into B. Then B into A. Then B into B, that is B square. And this is equal to what? A square plus B square. This is equal to A square plus B square. But what I'm suggesting here is A square, B square gets cancelled. So AB plus BA is equal to 0. So AB is equal to minus B. AB is equal to minus B. So we will multiply A and B. This A is A, this is B. And then we will multiply B and A. We will equate but with a negative sign. So let us multiply 1 into A is A. Minus 1 into B is minus B. Then 1 into 1, 1. Negative is positive. So you get 2. So 2 into A then. And minus 1 into B minus B. So 2 into 1 and minus plus. So you get 3. This is the left hand side. Right hand side. Right hand side will be what? We'll do the negative later. First let us multiply A1, A2, A plus 2. Then A into minus 1, that is minus A. And minus 1 into 1 is minus 1. So here B into 1 is B, minus 1 into 2 is minus 2. Then we have B into minus 1 is minus B, and minus is plus. So you have, so B into minus 1 is minus B, and minus is plus 1. Okay, negative is outside, so you just have to multiply negative 1 inside. So minus A plus 2 it will be, this will be A plus 1, this will be 2 minus B, and you can write this as B minus 1. It is not 1 minus B, it is B minus 1. I'll just change it. So A minus B, 2 minus A, 2, 3. Now let us equate. What is the equation? A plus 1 is equal to 2. And this is B minus 1 is equal to 3. This is 1 minus B, but it won't come. So this is going to be, let me write it as B minus 1. So B minus 1 is equal to 3. From here it comes A equals 1 and B equals 3 plus 1, that is going to be 4. So A is 1 and B is 4. Right? A1, B4, that is, this is the answer. B is the answer. Now A is given like this. A square equals I. Then you have to have this expression. This is alpha, beta, gamma minus alpha. And we are multiplying it again with alpha, beta, gamma and minus alpha. We'll equate with the identity. So there will be just multiplication, just equate, and that will be your expression. So alpha square, then plus gamma beta. It is not alpha, it is gamma beta. I'll just change it. Then alpha beta and minus alpha beta. So now here we have alpha gamma alpha or alpha gamma minus gamma alpha. Then we have beta gamma minus, actually it will be not minus, it will be plus alpha square. So this gets cancelled, alpha square plus beta gamma, and this is 0, this is 0, and this is beta alpha, and as I said, minus will become plus, and we need to add it. It will be B alpha plus alpha square equals the identity matrix, that is going to be 1 0 0 1. Okay, now let us equate it. See, alpha square plus beta gamma is equal to 1. You can take 1 on this side, and from second also you get alpha square plus beta gamma is equal to 1. In both the cases you get this, not beta alpha, beta gamma it is. Alpha gamma are mixing actually. So this is, but we need 1 as plus. If you see in the question, in the options being given, 1 is plus. So we have to multiply either both sides with 1, or you can take everything on the right hand side. That is going to become 1 minus alpha square minus beta gamma. Right? So we can rewrite this with negative multiplication or taking it on the right hand side as 1 minus alpha square minus beta gamma, because 1 is plus, as I just said. So the answer is C here, because it will be 1 minus alpha square minus beta gamma. So this is C. C is the answer. Now we have Sij is a scalar matrix such that Sii is k, and A is a square matrix of the same order, then AS into SA equals what? See, scalar matrix is nothing but the identity matrix multiplied by a scalar value. A scalar value. Right? So I'll tell you a trick here. In all these kind of questions, if I take this as, because 2 by 2 matrix, for example, so because SII is K, so that I and J are equal, so this is K in the diagonal. If I take K common from here, what do you get? 1, 0, 0, 1. Okay. Now it is saying that A is a square matrix of the same order, then A into S and S into A equals what? So I'll just take any matrix, and if I multiply any matrix with an identity matrix, A into identity will always be A matrix. So identity matrix into A will also be the A. Okay. So identity matrix into A is going to be A, and K is outside. So whatever you do, it will be K into A. This is the logic. If A is a square matrix such that A square equals capital A, then I plus A whole cube minus 7A is equal to. So we are going to use this A square equal A in the expression, and I plus A whole cube minus 7A. First we will try to find out I plus A whole cube. That is, we are not going to apply A plus B whole cube formula. That is not valid for matrix. So we'll first multiply A with A, that is this I plus A with I plus A. So I into I is I square, that is I only. Then I into A, then A into I, then A square. So what do you see here? A into I is A only. Anything multiplied by any matrix multiplied by identity matrix will be the same matrix. So what do you get? This is A, this is A, this is I plus A, 2A it is. Now A square is already given in the question as A. Since it is already given in the question A square equals A, we have to multiply this whole again by I plus A. I am again saying I plus A whole cube we are not going to do. That is not possible here. It may come same, it may not, but we have to follow the proper procedure. So in place of A square, we will be putting A. What are we going to put? A. So this is 3, I plus 3A. We have to multiply it with I plus A. Okay. Now let us do step by step. I into I is I squared. I already told you it is I. Then I into A. Then we have 3 into A into I. Then we have 3A into A. 3A square. So I square was I into A will always be A. This is A. This A into I will be A. And A square is A. This is A. So it will be 3A. I plus A plus 3A plus A with a 3. So 3A is 6A, A is 7. So this is I plus 7A. So I plus A whole cube was or has come as I plus 7A. Now you have a negative 7A. So just subtract 7A from here. It is going to be I. I is the answer. C is the answer. If a matrix A is both symmetric and skew symmetric, then see, we have already seen this can only be a zero matrix. I'll tell you how. Symmetric and A transpose equals A, that is symmetric matrix. A transpose equals negative A, that is going to be a skew symmetric. Right? In the transpose, Aij will change to Aji. That is the row and column we are exchanging. So Aij, when we are taking if we are saying that it is symmetric, then Aij has to be equal to Aj. This has come from the first relation, that is symmetric. Now when we take the skew symmetric, because it is being said A is skew symmetric also, Aij will be equal to minus Aj. Row and column will change. So now take this on the left hand side, Aij equals plus Aji is equal to 0. But from symmetric, Aij you can replace it by Aji. So you can replace this Aji by Aij. So Aij plus Aij is equal to 0. That is twice of Aij equals 0. We have utilized it here, okay? So 2Aij equals 0. Aij is equal to 0. Aij equals 0 means all the values are 0. Because Aij is nothing but it corresponds to all the value inside the matrix, and it is coming to be 0. Right? Just put all as 0. This is a 0 matrix. Answer is A. This is a 0 matrix. the matrix this is what? So we'll just take the transpose. Let us take the transpose. So this is the row, I'm making it as column 0, 5, minus 7. This is a row, we're making it as column minus 5, 0, 11, 7, 11, 0, that is 7 minus 11, 0. Okay. Now I'm taking negative outside, 0, 5, negative 7, negative 5, 0, plus 11, 7, negative 11, 0. Now what is this? This is again the same matrix in negative. So this is a skew symmetric matrix. So the answer, whenever A transpose is going to be equal to negative A, that is going to be a skew symmetric matrix. Skew symmetric matrix. If A is a square matrix, then A into A is a. See, A is a square matrix. A and A can be anything. We don't know. If you take any matrix, I'm just saying that if you take it as 1, 2, 1, 0 or any matrix, you cannot tell anything. It can be skew, it can be symmetric, it can be diagonal, it can be any of these. So by just saying that A is a square matrix, A dot A is what? You cannot tell, so you have to answer as none of these. Which one? None of these. Right? Just you can take an example 1, 2, 1, 0, you can multiply these two and just say that 3, 2, 1, 2 is coming. So A can be anything. If A and B are symmetric matrices, then A, B, A transpose. So you have to take the transpose of this. Okay, let us see. See, A, B, A. Since A and B are they are already symmetric matrices. Symmetric matrix already given. So A transpose is A, this is given. And B transpose is B, this is also given. We can directly use it. Now let us take the transpose. As I said, X, Y, Z transpose is a Z transpose, Y transpose, and X transpose. Okay. So for Z transpose, Y transpose, Z, X transpose. So A transpose, then we have B transpose, and then we have A transpose. So now A transpose is already given as A, B transpose is B, A transpose again A. So when we transposed A, B, A, we got the same matrix A, B, A. Okay, this is a symmetric matrix. A is the answer. Now A is given as 5xy0 and A is equal to A transpose. So what we have to do? A is A transpose. So let me do it. 5xy0 is equal to the transpose. Transpose is what? Row will be column. So 5x. This 5x will be, the first row will be the column 5x and this will be y0. So let us equate 5 is equal to 5, 0 is equal to 0, x is equal to y. So only we are getting x is equal to y. From this also and from this also, x is equal to y. So this question is only saying that x is equal to y. This is only what we can deduce from this question. X equals y. Okay. If A is 3 by 4 matrix and B is matrix such that A transpose B and B A transpose are both defined, then B is of type or B order is to be found out. Now A is given as 3 cross 4 and A transpose B is defined. So what happens in transpose? The row becomes column, column becomes row. So we assume that B is R into C. R is for row, C is for column. You can also take it as M into N. So this is 4 into 3 now. Because A has, we have taken the transpose. Now this into B is defined. So the row has to be equal to 3. Because the column of A transpose has to be equal to the row of B. Now B into A transpose is also defined. So B is 3 into C. We don't know C. What is A transpose? It is 4 cross 3. Now B into A transpose is also defined. So the column has to be equal to 4. So the row is 3 and column is 4. So 3 into 4 is the order. B is of type 3 cross 4. 3 into 4. A is the answer. If Aij is a square matrix of even order such that Aij equals I square minus j square. Now you'll see that some of the options are, part of the options are correct. But the answer is D. How? First of all, the order means even 2 by 2, 3 by 2, 4 by 4, sorry, and 6 by 6 like this. So let us take the example of 2 by 2. Now if we take the example of 2 by 2, this is 2 rows, 1 and 2. These are 2 columns, 1 and 2 columns. So this is A11, A12, A21, A22. Okay. Now you see, I squared minus j square, Aij. This is I squared minus j squared, that is 1 square minus 1 square. This is 1 square minus 2 square, 2 square minus 1 square, and 2 square minus 2 square. Okay, so what do you get? This is just an example. Okay, so this is 1 minus 1 0, 1 squared minus 4 is minus 3, and 2 2s are 4, 4 minus 1 is 3, and this is 0. Okay, so this is your A matrix. Now let us take the transpose of this matrix. When you take the transpose of this matrix, you will realize that it is actually a skew symmetric, because the A transpose will come as negative of A. So the A part, somewhat half of the A part is correct. That is, if I take the transpose, the row to column, 0 minus 3 will come here, 3 0 will come here, take the negative outside, it will be equal to negative of A. So this is indicating it is skew symmetric. But when we take the determinant is what? 0 into 0 minus of 9. That is 0 plus 9, 9 is the determinant. So the part here is all the options have no option determinant equals 9. Okay, so this is incorrect, symmetric is incorrect, skew symmetric it is correct, but determinant is 9. So none of these is the answer here. If A is given like this, A transpose plus A is identity matrix. So we'll take the A, that is this one, A transpose. So you can add A transpose with A or A plus A transpose, it remains same, because addition is so it is commutative. So we have cos theta minus sin theta cos theta. Here we have, let us take the transpose. So row will become column. So first cos theta will come, then we have minus sin theta. Here also the row will become column, sin theta cos theta, and this is equal to the identity matrix. Cos theta is 2 cos theta, minus sin theta is 0 when you just added sin theta, again minus sin theta, cos theta 2 cos theta. This is equal to 1 0 0 1. So 2 cos theta is equal to 1. So let me just write like this, 2 cos theta equals 1. So cos theta will be equal to half, and that is equivalent to half is basically, theta will be this pi by 3. Pi is equivalent to 180 degree, 180 by 3, that is, it will be cos 60 will be half. So you can just write cos theta as cos pi by 3. So theta will be equal to, when you generalize it, in trigonometry, we like the generalized equation, so it will be 2n pi plus pi by 3. C is the answer here. But you have to do it like this, whole procedure you have to follow. A is expressed as the sum of symmetric and skew symmetric, then the symmetric matrices. So we have already done this type of question, whole process, but here only symmetric matrix is asked. So symmetric will be half A plus A transpose, skew symmetric will be half A minus A transpose. We just have to find out S equals half A plus A transpose, that will be the symmetric matrix. So let us take this one, 2 0 negative 3 4 3 1 minus 5 7 2, and we'll take the transpose and add it. Row will become column. So 2 0 minus 3 will become column, 4 3 1 will become column, and minus 5 7 2 will become column. Now just add it, and then divide it by 2, that will be your answer. So you can do all, because this is a multiple choice question, so the answer will be what is being asked. But the whole procedure is like this. So I'm just adding 4 0 is this 3 3 6 7 1 8, minus 5 minus 3 is minus 8, 7 1 is 8, and 2 2 4. Okay, so we have to now divide it by half. So divide everything by 2, 2 2 minus 4, 2 3 4 minus 4 4 and 2. Now you just have to see this answer. This is the answer. This A1, A option is the correct answer. This is the whole process which has been described, but you just have to do this half A plus A transpose. Out of the following matrices, choose the matrix which is a scalar matrix. Now, scalar matrix has to be a square matrix. It cannot be like this. Means m by n it cannot be. It has to be n by n. Now, these three are not there because they are not square matrix. But the first one, A, is a square matrix, and a diagonal matrix in which all the diagonal elements are equal is called the square matrix. So here 0, 0. If you take the diagonal of the first one, they are equal. The number of all possible matrices of order 3 by 3 with each entry is 0 and 1. So there are 3 by 3, so 9 entries will be there. 3, 3, so 3 3s are 9. And each entry can be 0 and 1. So 2 possibilities, 9 places, so it will be 2 to the power 9. 512 will be the answer. Which of the given values of x and y makes the following pairs of matrix equal? So we just have to equate these two equations, and then you'll see that what is the option? 3x plus 7 equals plus this 5, y plus 1, 2 minus 3x, and we are equating it to 0, y minus 2, 8 and 4. So you see here, this y is equal to y minus 2. So from here it is clear y is equal to 7. And you can take any of these. Let us take this one. 3x plus 7 equals 0. X will be equal to minus 7 by 3. Also 2 minus 3x equals 4. So that will give you another option. Okay, minus this is, see, y is 7. But what about x? X is giving us two values. X is giving us minus 7 by 3 another value. So it is not possible. A is given like this and Ka is given like this. So K, A and B are to be found out. So we have multiplied this A with certain K, and that is giving you 0, 3A, 2B, 24. So Ka is 0, 3A, 2B and 24. Okay. Now what we are suggesting here is, you have multiplied something with minus 4 and then you got 24. Okay, that is going to give you the K value. That is, this x is actually K value. So we are just equating the corresponding value. So this K or x, whatever you call, it will be minus 6. So this K has come as minus 6. Using this K, we are going to find out the A and B value. Now 0 is will not take 0, but we have multiplied 2 with certain K so that we got 3. So 3, and also multiplied 3 with something that is called K equals 2B. K is negative 6. So K will be equal to 2. This B will be equal to 3 into minus 6 is 2B. B is 3 into minus 6 by 2. 2 3 is 6 minus 9. B is minus 9. And what is 3? 2 multiplied by K is 3. And A is 2 into minus 6 divided by 3. 3 2 is 6. Is going to be negative 4. So this is how this value has come. K, A and B. Okay. I, J and B. So I and J has to be placed in all of these options. And then you see when B is coming. Okay. So B is coming when you put, so you have to start with A option. Put I as 1 0 0 1, J as 0 1 minus 1 0 in the first equation here. So you have to multiply I with cos theta, J with your sin theta. So we are multiplying cos theta and then we are multiplying sin theta. What do you see? Just this is just a scalar multiplication. So cos theta will go inside, wherever 0 is there, just leave it. Now just add it. So it will be cos theta, this is sin theta, negative sin theta and cos theta. So this gives you what? This is B. This. So you have to see one by one, but we are fortunate that the first option itself has come. The trace of the matrix A. Now matrix trace is nothing but the addition of its diagonal. Okay. So can we find out the trace of any n by m matrix? The answer was 17 actually. Now if A is a scalar matrix of order n by n, such that ai is k for all I, then trace of A is equal to. So we can take any of the n by n matrix, that is 1 by 1, 2 by 2, 3 by 3 like this. Now this is a scalar matrix n by n. And all the values at the diagonals are k. That is, this is k, this is k. And since this is a scalar matrix, all other element has to be 0. So A11 is k, A22 is k, A33 is k. This is already given in the question. So I'm taking an example of 3 by 3 for example. So this, all the diagonals are k. Now the best way to understand this is, when you have I and J, k is there. Now this is k is common. you can take k outside. But what is this trace? K plus k plus k, and this is 3 by 3. But I am saying n by n, so it goes up to n. So when you take the sigma, it will be n into k. So the answer is A. Okay, this is all about this exercise. Thank you so much. Take care of yourself.